Basically, we have to complete this particular topic. That first we have to go for Newton's law. Today, we will just discuss the equation of motion. So first today I will just go for equation of motion. Equation of motion. And then I will go for FBD, free body diagram. That how you can make free body diagram and calculate the Newton's law, F is equal to ma. And then we will just try to do in one dimension first, 1D, and then we will go for this thing for 2D. This is most important thing for your exam, because once you will go into 2D, you will just try to learn Newton's law into polar coordinate, and then you will apply it on a Kepler's problem and basically sun and earth system. इसके बारे में हम बात कर सकते हैं. But before, you cannot directly jump on this. Before going to this, we have to learn little bit of how this free body diagram can be acted and how we can solve the Newton's law. So this is all the next session, next I think 4 and 5 class. We will just go up to this one, and then a separate session we have all about Newton's law into 2 dimension. Okay, so it's a very interesting topic. और ये टॉपिक हम लोग I think +2 से पढ़ते जा रहे हैं, और continuously whenever you will go, the finally everything will come to the Newton's law of motion. You can solve Newton's law of motion from the FBD. You can solve Newton's law of motion in a classical mechanics from the Lagrange's equation of motion. You can solve Newton's of motion from the Hamiltonian. Everything finally land at the Newton's law of motion, because it will tell you that how your position and momentum is varying with the time. Okay, so let's try to analyze this particular Newton's law. By the way, what is equation of motion? कोई स्टूडेंट बताएगा इक्वेशन ऑफ मोशन क्या है? बेसिकली आप क्या करते हो? फाइनली यू विल लैंड एट सम पॉइंट, एंड दैट इज पर्टिकुलरली नोन एज इक्वेशन ऑफ मोशन. व्हाट इज दिस पर्टिकुलर थिंग? क्या होगा ये? एनीबॉडी कैन टेल मी?
Force is equal to rate of change of momentum.
Exactly, force is equal to rate of change of momentum. Okay, so this is basically, if I am not going for the law right now, I will go for law in the next class, or maybe after next class. What we have to do, we have to form a second order differential equation, isn't it? So that second order differential equation, and obviously we are just talking about one dimensional system, 1D system. So what we have to do, we have to just try to solve it for the second order differential equation, something like m d square x upon dt square is equal to some function fx, and this is nothing but force, and this is just a rate of change of velocity or rate of change of momentum, and you can just find this is second order differential equation. So if you want to solve the second order differential equation, how many initial condition you need completely to solve this thing completely? Two initial condition, है ना? So, and that two initial condition will give you the complete solution of your position and your velocity. And once you got the position and velocity, what is benefit of this thing? अगर आप पोजीशन का टाइम के साथ इवोल्यूशन देख रहे हो, वेलोसिटी का टाइम के साथ इवोल्यूशन देख रहे हो, what will be benefit of that thing?
स्टेट पता चल जाएगा हम लोग.
Obviously, you know the state of a system, because state of a system in a classical mechanics is defined by position and its conjugate momentum. This is all about the state of a system. So now any physical quantity mainly used into the classical mechanics, any physical quantity can be represented in term of position and momentum, and then हमें क्या उसका फायदा होगा? We can see how, if I know how my position is varying with the time, if I know how my momentum is varying with the time, I can easily say how my any physical quantity. So if I have any physical quantity, that must be function of, and this can be any dynamical variable. This can be any dynamical variable. So this can be represented as a position as well as its momentum. So you can represent any physical quantity. A is nothing but one sort of physical quantity. So this is one sort of physical quantity. For example, you can take energy, you can take angular momentum. These two are very popular physical quantity, isn't it? है ना? And इसके अलावा कई ऐसे infinite number of physical quantity आप create कर सकते हो. This is beauty of classical mechanics. And then you can see how this physical quantity is evolving with the time. This dA upon dt, how this is evolving with the time. This is our ultimate challenge. And this is our ultimate thing that we have to solve it. So how you will solve it? This is a wonderful thing, isn't it? So we have to know how my position and how my momentum is varying with time. So initially we will start from here, and then we will see that there are different techniques. There are different techniques that without solving Newton's law, we can go up to this particular point. But initially we have to solve this particular thing, and then we can go for this particular analysis. So this is our ultimate aim for the analysis. Everyone is comfortable up to this?
Yes, sir.
चंचूर के अलावा और कोई स्टूडेंट?
Yes.
Yes, sir. Comfortable.
Yes, sir.
Comfortable. Very good. Very good. Good. So let's go for first. What is the simplest system you can think? अब मेरे साथ
Constant
साथ आप
force.
काम करने चलिए. What is simplest system?
Free
So
particle.
free
Free
body
particle, no force, isn't it?
Yes.
No force. That is moving with the constant velocity. So what will be this particular thing? M d square x upon dt square is equal to what? 0. Isn't it? No force. So first we are discussing all about free particle. अब आपका ये क्वेश्चन होगा कि यार ये मैं क्यों करवा रहा हूं, इसका पर्पस क्या है? Don't worry. When you will go for the advanced topic, such as Lagrangian, Hamiltonian, and analysis of Lagrangian, analysis of Hamiltonian, you can find that your Lagrangian is very complicated. Your Hamiltonian is very complicated. But ultimately, the solution is exactly like a free particle. Are you getting my point?
सर
हाँ बताओ.
ग्रेविटी के अंतर्गत जो पार्टिकल गिरता है वो भी तो फ्री
That is not a free particle. उसमें constant force लग रही है. Okay? है ना? फ्री पार्टिकल कोई फोर्स नहीं लग रहा है, कांस्टेंट स्पीड से चलती जा रही है. सिंपलेस्ट सिस्टम. बट दैट इज नॉट सो सिंपल. अभी इसलिए सिंपल लग रहा है कि हम तो डायरेक्ट रिजल्ट की बात कर रहे हैं. बट सम टाइम हम लोग कुछ ऐसे प्रॉब्लम करेंगे कि व्हाट यू विल गेट अ वेरी कॉम्प्लिकेटेड सिस्टम, वेरी कॉम्प्लिकेटेड एक्सप्रेशन, एंड देन फाइनली यू विल सॉल्व, देन इट विल रीच अप टू फ्री पार्टिकल. सो इफ दिस इज माय फ्री पार्टिकल, then obviously I can think, and I am just choosing m is equal to 1 for convenience. I am choosing m is equal to 1. ठीक है? If this is constant, so what will happen? dv upon dt is equal to what? Some constant, isn't it? dv upon dt is equal to some constant. This can be written. And what is your v? ct c1t plus c2. And this is nothing but what? v versus t plot करोगे तो क्या मिलेगा?
straight line.
Straight line.
With the y.
v versus t क्या होगा? सॉरी मैं सही कर रहा हूँ या गलत कर रहा हूँ?
Straight line with the y.
सॉरी this is 0 ना? There is some problem. Okay. Wait. So dv upon dt is equal to what? 0. है ना? dx upon dt, you can write this thing something like this. d upon dt, that will be dx upon dt, which is what? dv upon dt. You can solve differential equation in n number of ways. I am not an expert of differential equation. I am just using the first principle to solving the problem. Okay. So what will be the condition? V is equal to what? Some constant, isn't it? And what will be v versus t? What will be v
Straight
versus
line
t?
parallel
Just a
to
straight
the
line
time
parallel to
axis.
time axis. So
Yes.
every point you have same speed. Every time you have same speed, isn't it? This is your dv upon dt. Straightforward, simplest system. Now, what about dx upon dt? Is equal to sum c1. So dv is equal to dx up. So v is equal to dx upon dt. What is this x? c1t plus c2. What is this particular thing? कैसा होगा ये? How you can plot x versus
Straight line.
t? Obviously, this is a straight line,
Line
but
with the y
not a
intercept.
constant, है ना? Sum c2, suppose t is equal to 0 पर value कुछ मिलती है
Intercept
हमें.
y intercept
So
C2.
y will be intercept and this value is straight line. Okay. So this will be x versus t. What is this angle? Can you imagine what will be this angle?
The velocity.
Velocity, exactly. The tan of this angle is what? Velocity. Isn't it? This c, y is equal to mx plus c, isn't it? And what is value of m? M is nothing but c. So this tan of this theta is identified as velocity and which is always constant. So y, the slope is constant. So why we have v versus t at x versus t. This is a trivial system. This is a trivial system. One of the simplest system you can ever have. कहां पर देखो free particle कहां मिलता है? Where you have free particle?
Sir, Compton effect में दिखता है.
कहां पर?
Sir, Compton effect में.
Compton effect कहां पहुंच गया तुम? Particle confined in a box is a free particle, isn't it? That is
Yes.
a free particle. Particle moving in a horizontal line. That is what? Free particle. Horizontally up move कर रहा है particle. That is what? Free particle. There is not any force acting on this. This is free particle. और आपको मैं एक बात ये भी बताना चाहूंगा कि when you will go for quantum mechanics, you will not believe that only one system that can be completely solved is a free particle in a quantum mechanics. In classical mechanics, you can solve up to some level, but in a quantum mechanics, if you want to a complete solution, an ideal solution, then only free particle can give you the ideal solution. You can get other solution. आप बोलोगे सर हमने तो हाइड्रोजन एटम भी सॉल्व किया है, हार्मोनिक ऑसिलेटर भी सॉल्व किया है, डिराक डेल्टा फंक्शन भी सॉल्व किया. There are n number of system we have solved. Yes, you have solved, but with help of approximation, not with the ideal solution, not with the complete solution. Lot of approximation, lot of analysis, then finally you will get all these things. Are you getting my point? समझ रहे हो मैं जो बात कह रहा हूं?
Yes,
So
sir.
this is very important thing. The momentum is constant, velocity is constant, and the particle is just moving. Okay? Obviously, this is very trivial. इसके बारे में बहुत ज्यादा मैं time नहीं लूंगा. So this is your free particle. Next, the force. Constant force. अगर मैं force लगा रहा हूं, constant force. Can you give me the solution, the example where force is constant?
Gravity.
Gravity, a particle moving in a gravity. और कुछ बताओ? Just tell me. Any
Electric
other
field में.
solution? Huh? Particle in gravity. It's okay. Any other thing? बताइए example दीजिए. What is this value? Particle
Restoring
in
force.
a restoring force is not a free, not a constant force. Sorry, this is very
Yes.
complicated force. Anything else?
Correct.
So somebody is saying the video is paused. Sorry, this can be, I think, from your side, Minal. है ना? आप देख लो. I think आप लोगों के पास वीडियो आ रही है. Okay?
Yes, sir.
Yes,
है
sir.
ना? So मेरे तरफ से कोई प्रॉब्लम नहीं है. You have to just check. So example क्या हो गया? Particle in gravity. Okay? Particle in gravity. Now, another example. Just tell me.
Circular motion.
No. Oh my goodness. No. Circular motion is, by the way, 2-dimensional system. अभी हम ये 1-dimension system की बात कर रहे हैं. Okay?
Sir, viscous force.
No.
Friction force, sir.
No.
Surface of friction.
इलेक्ट्रिक फील्ड में
Exactly. Particle is in electric field with a charged particle moving in constant electric field, isn't it? So second is what? Charged particle moving in constant electric field. Okay? So these are the example of free particles. Sorry, they are example of constant force, not a free particle. So what will happen? So you have m dv upon dt is equal to some force, isn't it? Some force at which is constant, that is not a function of x, that is not a function of v. ये ना ही x का function है और ना ही ये v का function है. So this is just a constant. So how you will go for this? Again, I am just choosing m is equal to 1 and let's say this f is equal to some constant value. So dv upon dt is equal to constant and that value is equal to, what is v? Ct plus some c1. Now look at here, it's a very interesting. What will be your v versus t?
Straight line
with
Straight line.
y.
This is when you are going for v versus t, this is just something like this, isn't it? And now here you can say, this will just resemble to this one. Are you getting my point? Here I can plot x dot versus t. I am just writing x dot here. X dot versus t. Look at here. जो पोजीशन का प्रोफाइल फ्री पार्टिकल के लिए था, वही प्रोफाइल एग्जैक्टली आपका किसके लिए मिल रहा है?
Velocity के लिए.
Velocity के लिए when you have constant force.
Constant.
Look at, when you have constant force, you have exactly this sort of profile. Okay? Now, what will be your position? Position को कैसे करोगे? So whenever you will get a solution anywhere where position is directly function of time, अगर सपोज करो ऐसा कहीं भी आपको सॉल्यूशन मिल रहा है where position is exactly directly proportional to time, then obviously that is what? Free particle. And when your velocity is directly proportional to time, that means there is constant force which is acting on a particle, isn't it? So look at the resemblance. एक दूसरे को जरा किस तरह से attached हो रहा है चीजें, वो आप देखने की कोशिश कीजिए. Because always we have a fundamental that first we will choose a free particle and then we will make a complications on that and finally हम लोग उसको maximum to maximum complications में लेकर जाते हैं. You will see in this class itself. आप यहीं पर ये चीज देखना आप चाह पाओगे. Okay? Okay. Next, what will be your x versus t? कैसा होगा ये x versus t का profile?
So parabola.
पैराबोलिक.
Obviously, that will be what? Parabolic in nature. है ना? So you can easily solve this particular thing. आप इसे easily solve कर सकते हो. And this value is equal to what? dx versus dt is equal to ct plus c1t and x can be written as ct square by 2. Sorry, that is c1 and ct square by 2 plus c1t plus some constant, let's say c2. And what will be this profile? This profile is x versus t and which is something like parabolic in nature. Yes, this is something like parabolic in nature. Isn't it? This kind of thing you can have. So you have parabolic in nature. Up जैसे भी at t is equal to 0, I can have some value c2 and again it will increasing and it will go up to some limit. Now, let us try to make some complication to this system. Let us try to make some complication. And what we are going to do, we are just trying to take a constant force and we will try to add some velocity part. Constant force के साथ हम velocity को add करते हैं. then let's see what is going to happen, and then we will try to solve one problem. So let's try to go to straightforward solving one particular problem.
सर
हाँ बताइए.
सर यहाँ पे x डॉट वर्सेस t का जो ग्राफ आया है, यहाँ पे एट इन्फिनिट टाइम x डॉट को इन्फिनिट दिया जा रहा है, लेकिन सर x डॉट टू इन्फिनिट नहीं हो सकता ना, c
इन्फिनिट
लिमिट
टाइम
है,
इन्फिनिट कैसे होगा?
मतलब वेलोसिटी यहाँ पे
भाई आप तो टाइम का कुछ ना कुछ वैल्यू ही तो पुट करोगे. व्हाट डू मीन बाय इन्फिनिट टाइम?
सर x डॉट की बात कर रहा हूँ मैं
हाँ, आप कुछ ना कुछ तो वैल्यू दो पुट करोगे ना.
सर वेलोसिटी इन्फिनिट तो नहीं हो सकता ना.
क्यों नहीं हो सकता? वेलोसिटी बहुत लार्ज नहीं हो सकती क्या?
हाँ वो मतलब c तो लिमिट है उसका.
क्या सी लिमिट है? व्हाट डू मीन बाय सी लिमिट है? t is equal to 0, आई एम पुटिंग द c is equal to
नहीं
0.
सर मतलब वो मतलब वेलोसिटी ऑफ लाइट तो लिमिट है ना उसका.
ओह दैट इज डिफरेंट इशू. आप उसको रहने दो, मैं उस ओके वेरी गुड वेरी गुड. आपने देखो, वी आर जस्ट सॉल्विंग ऑल दिस प्रॉब्लम इन नॉन रिलेटिविस्टिक रेंज. आर यू गेटिंग माय पॉइंट?
ओके सर.
दिस इज assumption behind your Newton's law. आर यू गेटिंग माय पॉइंट? इन सब के पीछे हमारे पास ये स्टोरी है और ये कंडीशन है कि v इज वेरी वेरी लेस देन c. एंड प्लीज एक चीज आप हमेशा दिमाग में रखो कि हर एक चीज को मिक्स करने की जरूरत नहीं है. आर यू गेटिंग माय पॉइंट?
यस सर.
In general, you are obviously thinking like a good scientist because you are thinking like unification. Okay? And that is the ultimate aim of the science. That you have to talk about the unification of all forces. कि भाई एक unification लिख दे. लेकिन पहले तो आप सब चीज को separately ही पढ़ोगे ना. Are you getting my point?
यस सर.
So अभी हम लोग इसके बारे में बात नहीं कर रहे हैं कि स्पीड ऑफ लाइट हम पहुंच रहे हैं. Okay? This is very very less than the speed of light. We are talking about this tennis ball, football. Are you getting this thing? इसकी स्पीड के बारे में बात कर रहे हैं. ओके, वी आर नॉट इवन इन द माइक्रोस्कोपिक लेवल कि इलेक्ट्रॉन की स्पीड देख रहे हैं. इलेक्ट्रॉन की स्पीड क्या होती है हाइड्रोजन एटम में? 10⁶ के ऑर्डर की, isn't it? But we are not taking this thing in our consideration. We are just throwing the ball as a human being जो क्लासिकल नेचर की बात करता है. क्लासिकल नेचर और न्यूटोनियन मैकेनिक्स is always in v is very very less than c. हम मास को कांस्टेंट मान रहे हैं, अदरवाइज तो फिर सारे चीज कॉम्प्लिकेटेड हो जाएगा. देन योर मास विल बी फंक्शन ऑफ वेलोसिटी, isn't it?
यस सर.
है ना? अगर आप रिलेटिविस्टिक डोमेन में जाओगे देन दिस विल बी फंक्शन ऑफ वेलोसिटी. हमें ये नहीं करना है. वी हैव टू कंसीडर एंड वी हैव टू स्टिक आवरसेल्फ इन अ रेंज ऑफ वेयर वेलोसिटी इज वेरी वेरी लेस देन c. इस रेंज की बात कर रहा है. ओके, नाउ let us try to go for one particular problem and then we will try to mix each and everything together. एक बार हम एक प्रॉब्लम करते हैं, फिर इसको मिक्स करने की कोशिश करते हैं. ओके, नाउ द इक्वेशन ऑफ मोशन इज गिवन बाय, लेट्स ट्राई टू गो फॉर दिस. और ये फॉर्चुनेटली एग्जाम में भी आया हुआ है ना. So let's try to go for this. आप देखो फर्स्ट डे का ही क्वेश्चन सीधा सीधा एग्जाम में. So look at this particular thing. So equation of motion is given by, मैं बाद में बात करूंगा किस तरह के मोशन की बात कर रहे हैं. First we have to solve it. The equation of motion is given by md square x upon dt square is equal to mg minus gamma dx upon dt. इस तरह की हम प्रॉब्लम के बारे में सॉल्व कर रहे हैं. दिस इज सम, ये भी फोर्स है तो ये भी क्या होगा? 100% फोर्स होगा, isn't it?
Yes,
है
sir.
ना? So this will be this is gamma is has such a dimension which will give you the equation of, this is just a force equation. Okay, so and what we are going to, for the solution we are just trying to put that g is equal to 10 unit. We are just trying to take g is equal to 10 unit and gamma is also 10 unit. M is equal to 1. So we just try to solve this for this particular number. Because number is very important. है ना? उसके बगैर आप एनालिसिस करना आपके लिए बहुत मुश्किल होगा. By the way, which type of system we are talking about? किस तरह का सिस्टम की बात कर रहा है? Just tell me.
damping.
Obviously,
Damped
you can what? Sorry. You can take a particle and you can just send this particle in a oil, isn't it? Oil के अंदर particle को छोड़ दिया, and you have very long tunnel, या फिर आपको कुछ constant velocity से frictional some viscosity आपके पास लग रही है किसी तरह से, you can have this sort of system. Okay, and you are just throwing this particle inside this particular oil. Okay, this kind of system you have, and this is just moving inside this particular thing. Okay, let's try to go for this. Let's try to solve this particular problem. How you will solve it? So you will just go for dv upon dt is equal to 10 minus 10 v, isn't it? dv upon dt is equal to, and sorry, just a minute, शायद मैंने कुछ पैरामीटर गलत ले लिया है. Just so just take gamma is equal to 1, है ना? Take gamma is equal to 1. Just take gamma is equal to 1. Okay, so this is 10 minus v. So this is your actually exam problem. So dv upon dt is equal to 10 minus v. इसे solve करना, very simple problem, and it is also given at t is equal to 0, your v is equal to 0, and at t is equal to 0, your x is equal to also 0. Okay, so obviously this is second order differential equation, so you need two initial condition to solve the problem. So these are the two initial condition. So how you will solve it? Very simple to solve. आप तो बहुत आराम से इसे solve कर लोगे, है ना? That is 10 minus v is equal to dt, and this is just going something like this. Okay, now how you will solve it? You can just put 10 minus v is equal to what? Y. So you can just put minus dv is equal to dy, and you have something dy upon y is equal to minus dt. And then finally we will put it. What is this particular thing? ln y is equal to minus t plus some constant c1, isn't it? है ना? Am I correct? So I can write y is equal to some constant alpha e to the power minus t. अल्फा ई टू दी, इसको इधर ले जाओगे तो ई टू दी पावर c1, उसको हम क्या कर रहे हैं? अल्फा के टर्म में लिख सकते हैं. सो दिस इज माय सॉल्यूशन. एंड व्हाट इज y? y is equal to nothing but 10 minus v is equal to alpha e to the power minus t. Now we have to calculate the value of alpha. How you will calculate the value of alpha?
initial condition.
Huh? Initial condition. Sorry.
इसमें dv by dt equals to 10 minus v by m नहीं आएगा?
m को 1 यूनिट ले लिया ना?
Okay,
ठीक है. So now put the initial condition. What is initial condition? T is equal to 0, v is equal to 0. So 10 minus 0 is equal to, what is value of alpha? We have to calculate value of alpha, e to the power minus 0. So alpha is equal to what? 10 unit.
10.
Alpha is equal to 10 unit. Okay. And now if alpha is equal to 10 unit, you can put the value, and what will be v? V is equal to 10 1 minus e to the power minus t. Okay. Now I am just giving you 30 seconds. मैं आपको 30 सेकंड दे रहा हूं. Just try to plot v versus t. जरा प्लॉट करो तो. What will happen v versus t? Just I am giving you 30 seconds. Just try to plot v versus t. What will happen?
Exponentially decrease करेगा time के साथ.
सोच लो. Very interesting. सीधा सीधा 5 मार्क्स आया था जिस साल आया था एग्जाम में.
सर
हाँ,
सर
नेट के
10 पे
एग्जाम
जाके वो 10 पे
क्या?
जाके वो कांस्टेंट हो जाएगा. टी जब बढ़ेगा तो मतलब
हाँ,
एस कार वैसे हो जाएगा।
वेरी गुड वेरी गुड, मैं समझ
जीरो।
रहा हूँ। हाँ ठीक है, जीरो से क्या होगा, ये बढ़ना शुरू करेगा, इजंट इट?
यस सर।
जीरो से ये बढ़ना शुरू करेगा। लुक एट दिस, वेरी सिंपल एंड वेरी इंटरेस्टिंग। देखो, सॉल्व करना इंपॉर्टेंट नहीं है, उसके अंदर की स्टोरी क्रिएट करना इंपॉर्टेंट है। व्हाट विल हैपन, you just want to go for v versus t. Now at t is equal to 0, v is equal to what? 0. Yes, 1 minus 1 is equal to 0. So it will start. And what will happen, as time increase, this value will be going to decrease, isn't it?
यस सर।
Because it is minus sign, e to the power minus sign. So what will happen, this value will initially increase, and after some time, what will happen? Initially its value is increased, and after some time it is just going for the saturation, isn't it?
यस सर।
And now what will happen? Now look at the trend. Look at the trend. After this point, this is just behaving like a free particle, isn't it?
यस सर।
फ्री पार्टिकल का तो अभी देखा था ना आपने, क्या देखा था? ऐसा ही तो था, v versus t, something like this, isn't it? V versus t, you have this particular straight line, and if you will go for this particular curve, you will find that after some time t naught, the particle is just behaving like a free particle. Are you getting my point? It will achieve the equilibrium. Are you getting my point?
Yes, sir.
यस सर।
है ना? So now you can see there is force. अब आप देख लो सारा कहानी को, क्यों मैं कह रहा था कि free particle is very important thing. You have force, you have damping on this force, and this force, these two forces will just try to oppose each and each, just try to oppose. This mg will try to oppose this, and this mg, this will try to oppose this one. And what will happen? After some time, what will happen? It will just achieve the equilibrium, and whole thing is equivalent to 0. At this particular point, when it is just going as a straight line, and what is this particular value? This particular value is 10, isn't it? At t tends to infinity, you will get this value is 10. And now you can see you are not getting absolutely infinite velocity, isn't it? Even if time is going larger and larger. Are you getting my point? So this
Yes,
is
sir.
a realistic system. This is the realistic system. You can easily say, and you can see that there is a free particle sort of thing. By the way, you can calculate what is x versus t. Can you calculate what is x versus t? Yes, very easy. क्या होगा बताइए?
सर
बताओ.
सर ये जो v वर्सेस t का हमने ग्राफ बनाया है अभी, इसमें ये t तक पहुंचेगा नहीं ना?
टी तक क्यों नहीं पहुंचेगा? टी
Tends
तक
to
पहुंचेगा
t
नहीं मतलब ये तो समझ में नहीं आ रहा है.
सॉरी मैं गलत बोल रहा हूँ, t बोल रहा हूँ, 10 तक नहीं पहुंचेगा ना?
हाँ, 10 से नीचे ही रहेगा obviously.
Yes, sir.
That is just upper limit is 10. So you can say this is your threshold. So बहुत ज्यादा टाइम के बाद आप you can कह सकते हो it will go to 9.999 and
Yes.
actually it will go to 10 actually. You can assume क्योंकि हम लोग basically बात कर रहे हैं in a that limit where we can take that thing as a error. Okay?
Yes, sir.
हाँ ना?
सर x वर्सेस t में दो टर्म आ रहा है सर, एक तो स्ट्रेट लाइन वाला टर्म और एक एक्सपोनेंशियल डीके वाला टर्म.
ना देखते हैं कैसा होगा. Let's try to say this particular thing, है ना? So let's try to go for a straight line. So dx upon dt. So what, when we will go for dx upon dt, then obviously this is 10 minus 10 e to the power minus t. So what will be your x? 10t, और ये वाला क्या हो जाएगा? प्लस हो जाएगा ना? प्लस 10 e to the power minus t, और प्लस सम कांस्टेंट c1, एंड अगेन t is equal to 0 पर x की वैल्यू क्या है? 0. So C1 is equal to what? Again 10. ऐसा ही तो है ना? Sorry, C1 is equal to
t is equal to 0, x is equal to c1 आएगा ना?
wait. T is equal to 0. This value is 1. This value is 0. C1 is equal to minus 10, isn't it? C1 is equal to minus 10. So x is equal to 10t plus 10 e to the power minus t, and this value is minus 10, something like this. Now what will happen? Initially you can see this is this curve, and this curve. There are three curves. This curve is, first curve is just moving like this, isn't it? First curve ऐसा move कर रहा है. Everybody is agreed? The second
Yes, sir.
curve is moving like this, isn't it? This one. And third curve is some constant value. Okay? minus 10 इधर से रख दो. Some constant value, है ना? So constant value का तो कोई effect नहीं है. Initially थोड़ा बहुत हो सकता है. And t is equal to 0 पर x की value 0 है. So there is not any problem. What will happen? After very large time, this term is not going to dominate. Which is going to dominate?
10t.
10t.
10t is going to dominate at the large time, isn't it?
Yes,
Large
sir.
time पर कैसे? Obviously होना भी चाहिए था, because this particle is just like as a free particle. So what will happen to x versus t for that particular free particle? Something like a straight line, isn't it?
Yes, sir.
भाई free particle के लिए x versus t आपने क्या देखा था? This is something like x versus t, and that will go something like a straight line. When you have this situation of velocity, you have this situation of position, and you have x versus t something like this. So obviously, initially what will happen? If we are just going to plot x versus t, then obviously, initially we will start from 0. It will take some curve, and after then it will be more or less a straight line. When it is start to behaving like a straight line, exactly at this particular point, isn't it?
Yes, sir.
है ना? ये थोड़ा इसको नीचे करने की कोशिश करेगा, थोड़ा स्लोप चेंज करेगा, बिकॉज ये डीके कर रहा है, तो थोड़ा स्लोप चेंज होगा, बट फाइनली इट इज जस्ट गोइंग टू डोमिनेट दिस वन, एंड इट विल जस्ट गो फॉर अ स्ट्रेट लाइन. आर यू गेटिंग माय पॉइंट? है ना? सो लुक एट हियर, दिस इज वंडरफुल प्रॉब्लम. अब एग्जाम में तो अभी तक ये आया था, इसका सॉल्यूशन आया था. हो सकता है नेक्स्ट बार इस तरह के कर्व आ जाएं. नेक्स्ट टाइम आपसे ये पूछा जाए किस टाइम के बाद आपका इन्फिनिटी पर क्या बिहेवियर है, किसी पर्टिकुलर टाइम पर क्या बिहेवियर है. यू कैन जस्ट ट्राई टू गिव दिस आंसर, isn't it? But now you can see, if you know the basic fundamental system. And what is the basic fundamental system? The basic fundamental system is free particle. The basic fundamental system is your particle which is moving with a constant force. These two are the one of the very basic fundamental system. And what will happen? If you know the exact solution of these two things, you can analyze the solution of the complicated system, something like this. Are you getting my point?
Yes, sir.
Yes.
है ना? So this is and this example is one of the very beautiful example. कई बार different types से different exam में आया हुआ है. Okay, so you have to just try to see this type of problem. Okay, now next we will try to go of very, very famous potential, linear potential, or very, very famous force. That is what? Linear force. Linear force की ब्यूटी क्या होती है वो हम जरा देखने की कोशिश करेंगे. Are you people ready to analyze this thing, linear forces को?
जी सर.
है ना?
Yes.
अभी तक आप
Yes.
देख रहे हो, just look at your velocity and position have entirely different trend, isn't it?
Yes, sir.
है ना? Obviously, they have some different trend. Now look at when force is linear. What is beauty in the linear force? You have to just feel this particular thing. And why linearity is so important in a physics? Let's try to understand this one. Okay? Let's try to go for this. So this is a very interesting. मैं जब भी इसे करता हूं तो मुझे बहुत मजा आता है, because you can फ्यूचर में जो आप प्रॉब्लम सॉल्व करोगे उन सारे प्रॉब्लम का बेसिक सोल इसी पॉइंट पर आकर के आ जाता है. ओके, नाउ लुक एट लीनियर फोर्स. आई एम नॉट सेइंग अबाउट द हार्मोनिक ऑसिलेटर और समथिंग प्लस और माइनस, उसके बारे में नेक्स्ट क्लास में बात करेंगे. बट टुडे आई एम जस्ट ट्राइंग टू टॉक अबाउट योर m d square x upon dt square is equal to, let's say, some kx. Are you getting my point? Sometime you will get minus kx, sometime you will get plus kx. That is different issue. I'm not going into that part. I will go into that part in the next class. But today I just want to see the equation of motion. Now, let's say m is equal to 1 and k is equal to 1. For the simplicity, to understand the symmetry, can I write d square x upon dt is equal to x? Why it is linear? Because x to the power 1, and which will tell you all about the linearity. So d square x upon dt square is equal to x. Okay. Can I write this whole thing as d upon dt x dot is equal to x? लिख सकते हैं क्या?
Yes, sir.
लिख सकते हैं. Look at, I am just going to differentiate both sides with time. Then what is going to happen? You have d upon dt x, sorry, d upon dt x dot, एक मिनट मैं क्या कर रहा हूं, dx dot is equal to this thing, and what we are going to do, I am just writing x dot here. So d upon dt d x dot upon dt is equal to x dot. ऐसा लिख सकते क्या? Yes या no?
Yes, sir.
Yes.
लिख सकते हो. So can I say d square x dot upon dt square is equal to x dot? Yes या no?
Yes, sir.
It's
Yes,
very
sir.
interesting. Now, if you will just try to analyze these two equations, the solution will be exactly same type of solution, isn't it? नहीं क्या?
Yes, sir. Yes, sir.
x का भी solution कैसा होगा? जैसा x का solution होगा, exactly same nature. I am not saying exactly same, but the profile is solution is same. Are you getting my point?
Yes.
Yes, sir.
The profile of x and x dot is same. And when your force is linear, you can use this information in a very nice way. Any other force और किसी भी तरह के force में ये beauty और ये beautiful symmetry नजर नहीं आती है. For example, आपने free particle देखा, x और t का profile बिल्कुल क्या है? Obviously both are straight line, but profile is entirely different. One is moving with the, one is just varying with the time, another is constant with the time. You are just visualizing this thing for your constant force. You have that velocity is a straight line and your position is just a parabolic equation. But here you can say, if you know the solution of this x, you know the solution of x dot. And profile of both are exactly same. Maybe there is some changes in the constant, but profile, the nature is exactly same. Yes?
Sir, ये symmetry किसी और में नहीं होता ना?
No, not any other system. And this symmetry is only and only into what? Your free,
Linear force.
only on linear force. Isn't it? And this type of force is basically what? Harmonic force, restoring force. Isn't it? इसके बारे में हम बात करेंगे. ठीक है? So don't worry. We will just try to solve one time with plus k, another time with minus kx, and then we will see which type of solution can be there. And then again we will introduce the velocity part and we will see what is going to happen into next class. Are you people happy?
यस सर।
ठीक है। So this is from my side of first class, that is equation of motion. हम लोग कल इसी को आगे बढ़ा करके ले जाएंगे. We will just try to see the oscillatory solution, decaying solution, and then we will add the velocity part. Then you will see damping, damped oscillation, and this type of solution you can easily assume. ठीक है, इसको हम लोग कल की क्लास में करेंगे, and then we will go for a free body diagram. Okay. Yes.
ट्यूटोरियल में ये कौन से पार्ट में है?
Sorry.
सर जो हमारे पास ट्यूटोरियल है उसमें कौन से पार्ट में ये एक्सप्लेनेशन
ये किसी भी ट्यूटोरियल में नहीं दिया हुआ है, ठीक है।
ओके
ओके, ये मैं एक्स्ट्रा आपको करवाता हूं क्योंकि आगे जाकर के आपको हर एक जगह पर इसका यूज होगा, तो यू कैन थिंक दिस इज इन एवरी ट्यूटोरियल। ओके, है ना। सो दिस इज बेसिकली वन टाइप ऑफ टूल्स। हम लोग एक टूल्स के बारे में बात कर रहे हैं, ठीक है, और उस टूल्स को कैसे एनालाइज करना है उसके बारे में बात कर रहे हैं। ओके ओके, सो जितनी मैं क्लास में करवा रहा हूँ दैट इज मोर देन एनफ, उससे ज्यादा आपको करने की जरूरत नहीं है ना। बहुत ज्यादा अपने आप को दिमाग इसके अंदर मत लेके जाइएगा। ओके, बिकॉज सिर्फ लीनियर तक ही हम सॉल्व कर सकते हैं। अगर के एक्स स्क्वायर आ जाएगा इट्स ओवर, हमारे बस में नहीं है उस चीजों को एनालाइज करना। फॉर दैट यू हैव टू लर्न नॉन लीनियर डायनेमिक्स, यू हैव टू यूज कंप्यूटेशनल और बाकी सारी चीजें आप करते हो। ओके ठीक है, सो डोंट थिंक दैट कि आप कुछ भी सॉल्व कर लोगे, है ना। देयर आर लिमिटेशन। सो इससे आपको ये भी फायदा होता है कि आपको ये पता है कि आपके सॉल्यूशन कुछ आसपास इसी के रहेंगे, है ना।
ओके सर,
ठीक है, सो दिस इज वेरी इंपॉर्टेंट। ओके, थैंक यू।
थैंक यू सर।
थैंक यू सर।
थैंक यू।
Thank you.